Hello everyone. I hope everyone is staying safer at home. That's the fancy new term that I learned today thanks to the order issued by Governor Evers. Looks like we are all going to be stuck at home for quite a while, which I think is a good thing because we can spend a lot of time with family. I'm having a lot of fun with my son. I hope all of you are staying cheerful and keeping yourself occupied and spending a lot of time with your families as well. All right, so this video lecture is all about generator functions and iterators. Before I dive into today's new topics, I want to do a quick review of the last two topics which we have covered as part of CS220 lectures. So that's going to be recursive functions and functions as objects. So let me switch to Jupyter Notebook. So take a few minutes to read the two functions which you see on the screen over here, and feel free to pause the video here and answer this following question. So which one of those two functions is an example of a recursive function? So if your answer was mystery, then you're correct. So let's take a look at why exactly mystery function is recursive. So as you can see, the mystery function is calling the mystery function, which is itself. This is an example of a direct recursion. Alright, so let's take a look at the other example over here. So the other example has a function which is defined, which is called the raise 10 function. Clearly the raise 10 function is invoking the mystery function, and if you take a look at this particular cell, you'll notice that I'm passing a reference to function object, which is for the raise 10 function, by using this particular function name itself. So how can I say that this is just the function object reference and not a function call itself? I can say that by the missing parenthesis. No parenthesis means that I'm passing the function object reference as an argument to another function, which in this case would be map. Alright, so let's take a look at the details of the mystery function. So I'm going to get started by asking you what mystery of 2 comma 1 is going to return. So let's trace that manually. So clearly the value of x is 2 and the value of y is 1, because these are positional arguments. So what happens when y is 1 is that we just return x. So mystery of 2 comma 1 is going to return just 2. Alright, so let's take a look at what mystery of 2 comma 2 returns. So x is 2 and y is 2. Clearly y is not 1. So this line of code will get executed, and we are trying to return x into mystery of something. So x is 2 into mystery of x comma y minus 1. So x is 2, y minus 1 is 2 minus 1, which is 1. Mystery of 2 comma 1 is 2. We already know that. So this is going to get evaluated to 2 into 2, which is going to be 4. So mystery of 2 comma 2 returns 4. Similarly, mystery of 2 comma 3 is going to return x into, which is x is 2, into mystery of 2 comma y minus 1, which is 3 minus 1, which is 2. We already know that mystery of 2 comma 2 is 4. So this is going to return 2 into 4, which is 8. Alright, so if you're following the same execution, and by now you should have guessed what the mystery function is for. Mystery of 2 comma 4 is going to be 16. So what exactly is the mystery function doing? Mystery function is just an equivalent of x to the power y. So mystery of x comma y is the same as x raised to the power y. Alright, so let's take a look at the second example over here. So what is it doing? We have a raise 10 function which is taking as argument a value. So what is it doing with the exponent value? So it's just invoking the mystery function, and it's raising 10 to whatever exponent is passed as an argument to this function. Alright, so with this function, suppose I have this requirement where I have a list of numbers, and I want to raise 10 to the power each of those numbers. Recall that you can use the map function to do this. What map function does is that it applies whatever function is passed as the first argument. So this is going to be a reference to the function object, which is given by raise 10, and the second argument is going to take in a list. So the map function applies this particular function to each of the items in the list that you pass. So let me go ahead and run this. So as you can see, if I run it, we just see this weird generator object which the map function returns. So recall that we can typecast generator objects into lists. So if I go ahead and do that, as you can see clearly, the map function is raising 10 to the power 1, which is 10, and 10 to the power 3, which is 1000, and so on. So let me actually, I missed mentioning something with the mystery function. Let me go back to the mystery function. So what I wanted to mention was that whenever you have a recursive function, you need to focus on this fact that whether your recursive case is making progress in such a way that you will eventually reach the base case and your function will actually be done. So what do I mean by that? Clearly this is the base case and this is the recursive case. So whenever you have a recursive case and a function calls itself, you need to make sure that some of the parameters, that some of the arguments that you're passing to the next function call is somehow changing in such a way that you will eventually hit your base case. And in this particular example, how are we achieving that? Note that the value of y here is the one which is getting updated, and every time it's getting decremented by 1. So what would happen eventually is that eventually your y value becomes 1 and your function call will hit the base case and it will return at some point. Hopefully both of these concepts are quite clear. Let me switch back to my slides and let's discuss today's lecture topic, which is about generator functions. Alright, so generators are these radical functions which are different from the regular functions that we have discussed so far. So what is so different about them is that a generator can keep running even after the function call returns back to the normal flow of execution, and we'll see how exactly that is achieved through a generator. So I'm going to actually cover a generic example on a function first before giving you a motivating example for why generator is needed. So pause the video here for a few minutes and read this snippet of code carefully before trying to answer this question down here, which is asking how many times does the word start get printed. So by looking at this function definition, so this term, the string start is coming from this particular print line, which is part of the get one digits num function. And as you can see, that function is being called from this particular line, which is part of this for loop. So if your answer to this question was start gets printed just once, then you have the correct answer. But if you were thinking of like a higher number, let's say 10 for instance, then let me actually explain to you why that is not correct. So the way that you need to think about regular function calls when they are used in a loop is that you need to assume that this particular function call gets executed fully, and this is replaced by whatever is the return value that gets returned by this particular function. So let's go and take a look at what this function exactly does. So as you can see, it initially prints start, and it initializes an empty list, and it has a loop which adds a bunch of numbers to that list, and then it prints end and it goes ahead and returns the list that we just generated. So the way that you need to think of this particular function call is that gets replaced by the list that gets generated when we call that particular function, and in this case the list is having items from 0 to 9 as per the while loop over here. Alright, so if we draw a timeline diagram of how the execution of this snippet of code happens, and suppose I tag the part of this function as dark black in color, and what am I saying, just black in color, and if I tag the for loop statement as gray in color, this would be the timeline that is being followed for the execution. Initially the function call will happen and the function will print start, and it will go ahead and append all the numbers to the list called nums, which is going to form stage 1, and then it will go ahead and print end, and it will return the nums, which is the list which we just populated as part of stage 1. Okay, what will happen after that is then your for loop will start executing, and each of those print statements will print each of the numbers that we just appended into that list, which is going to form stage 2 when it comes to execution of this code. Alright, so the next example that I'm going to cover is the motivation for why generators are really needed. So as you can see, if I quickly switch back and forth between the two examples, they are quite similar in nature. So take a few minutes here again and pause the video and try to understand what this function get underscore primes here does. So you have to assume that there is an earlier function which covers the s underscore prime functionality. Assuming that what is different between the previous example and the current one, as you can see, unlike the previous example, we have a infinite while loop in this particular example. So what is it trying to achieve? It's trying to keep going until it finds all possible primes. That's not going to end anytime, right? So for all practical purposes, this program is going to keep running forever. So as you can see, the intention probably here is not for generating all the primes and then executing this for loop to print every prime number, right? Because you can keep finding prime numbers as you keep going. So how do you actually solve this kind of a problem where you want to keep working on parts of a problem and then keep processing the results as it gets generated? So the solution to such a scenario is the usage of the generator function. So let's talk about the timeline for a generator function. So what exactly we want is that we want to generate one prime number, and then we want to actually do something with the prime number, which in this case would be printing the prime number, and then we want to go on to find the next prime number. So what we need is sort of this pause and resume functionality which we need from a generator. So I'm throwing a term here for this kind of a function which is called as a lazy function. So why is it called a lazy function? That's because we know that the get primes function is not actually done doing all of its work, and that it's only done finding the next prime number, and then it needs to be prompted again to go back and find the next one after that. So this is in contrast with the eager function example which I covered before this. So the difference between eager and lazy is that an eager function actually finishes its entire execution before returning the value, whereas the generator is considered a lazy function. Alright, so how do we actually achieve this stop and resume sort of behavior is by using a generator. And how can we use a generator, or how can we make a function to be a generator? So the way to do that is to have a yield statement. So any function which has a yield, no matter where the yield is positioned as part of the function definition, is considered a generator. So why exactly are we using the same keyword def, which stands for function definition, for a generator, and not using a different term like keyword like gen, when clearly this is a whole lot of new functionality when compared to what regular functions do? So who gets to decide such questions or like such decisions in Python is somebody who is called as Guido von Rossum. So he, whenever there is a conflict, he takes into consideration how to evaluate the pros and cons of that particular situation. In this case, it's like, should we introduce a different keyword for a generator? So if you go and click on this link, you will see that what sort of pros and cons he considered in order to deal with this issue, and how exactly he came up with a solution for that. So in this particular case, he just decided that a yield statement is not too much of a difference from a regular function definition. So he decided to go with the keyword def instead of the keyword gen over here. All right, so that's some background. Let me actually give you an example for yield and generator function in general. So we are going to consider a simple example to understand how yield works, and then I'll go back and talk about how we can switch the second problem to use yield. All right, so let me switch to Python tutor. Alright, so let's get started with a very simple example. Suppose I want to define a function f, and I want it to return three values 1, 2 and 3. Suppose I just like add three return statements, and I call the function and I want to print what the function is actually returning. Let me step through from the first. Alright, so we have the function definition, and then the function f is being called, which creates a new frame. So a return statement is hit, and as soon as the return statement is hit, the function call gets done, and the frame actually gets destroyed, and nothing else in the function will get executed after that. So how do we convert the same example into a generator function for the same function f? The way that you do that is you need to replace all the return keywords with yield keywords. Alright, so as you can see, when you do that, right now you have a generator called f, and if you try to print f, it sort of prints this weird generator object. I'll talk about how to use generator objects shortly, but before that, let's take a look at how you can actually get the values out of this generator. The way that you would do that is you need to write a for loop saying for let's say val in f, and you can do things like print val. So let me step through from the first over here so that we can see what exactly is going on and how to use the generator. So once you have the function definition, so what this loop is going to enable is it's going to actually keep calling your generator function every time the function returns a value. So the first iteration would actually call f function. So the function call then hits this statement which is the first yield statement, and yield will go ahead and return the value of 1 outside. So your val is now going to contain the value 1, and what will happen after that is 1 gets printed. So one thing that I want to emphasize is, let me actually step back here, is that Python Tutor doesn't give you a good visualization of generators, unfortunately. So Python Tutor actually made the frame for f disappear after stepping through the first iteration, but that's not actually correct. It should actually have the f frame continuously up here until the generator is done generating all the data. And another thing you'll notice is instead of saying yield value, it's actually saying return value, which is unfortunate. I wish Python Tutor had proper visualization for a generator. Alright, that said, I was talking about how the first value gets generated and it gets printed after it goes into val. So what will happen when you hit next is that it will, your function execution, instead of starting at line 1, actually now starts at the last line that you left in terms of executing the function. Last we left that function at line 2, so that's where we are going to actually go back, and what would happen now is it will go ahead and run the next line, which is line 3, and now the function yields 2. So val gets populated to a value of 2 now, and it will go ahead and the for loop will go ahead and print that particular value. So stepping through again, what would happen is last we left the function at line 3, so your execution will go back to line 3, and after that it will go ahead and yield 3, which is now going to go into the variable val, and when you print val, that prints 3, and your whole program will be done after that. Notice that in your for loop, it actually goes back to the last line, which is line 4, and then it will see that there are no other lines to execute in function f. And what will happen then is you get a nothing gets yielded from that function, and here is something which happens, which is called as an exception. So this is going to be covered as part of the next lecture, but I just want to briefly mention that stop iteration is an exception which enables Python to exit out of this loop and finally tell that okay, it's done executing this particular piece of code. Hopefully that example makes sense. So let's make it a little bit more clear. So whenever I say that when you have an yield, that is what is going to make your generator give that value. So what exactly I mean by that is that, let's say you add more print statements to this particular function. Let's say I print a before yielding 1 and print b before yielding 2 and print c before yielding 3. Let me step through from the first so that you can actually see what's going on over here. So what would happen with the first invocation of this generator is that the function call will step in, it will go ahead and print a, and it will move on to the next line because it hasn't hit a yield yet. So it will keep executing until it hits a yield statement. So as soon as it hits a yield statement, it will go ahead and yield that value. So the function call will get now paused. So which is the pause and resume feature which I was talking about when it comes to a generator, right? So as soon as the function call pauses, the flow of control goes back to the for loop where you're making the generator call, and then you once again print whatever is being yielded by the function, which goes into the variable val. Then when the next generator function call is made, observe that once again the code execution starts at line 3 where we left off last, and then it will go ahead and print B, and then it will search for keep running until it hits the next yield, which is now going to yield a value of 2. So val becomes 2 and 2 gets printed, and similarly C gets printed and val becomes 3 and 3 gets printed. Alright, so the next thing that I wanted to show you is how can you actually create two different invocations of the generator function. Before I go ahead and show that, let me actually replace this val variable with the variable name x. I just realized that I was using x in my PowerPoint slides, so let me go ahead and do that so that there is no confusion. So let's get rid of all these additional print statements and let's go back to the simpler example. The way that you can sort of restart your generator from the beginning, or think about this as like executing the generator one more time, would be for you to add another for loop. So let me step through from the first. I'll just like step through a few iterations of this particular example. So what would happen when you have the first for loop is that your generator frame f gets created and it will yield 1. You go ahead and print 1 as x becomes 1, and what would happen next is you resume at yield 1 statement execution for this particular generator object instance, and you go ahead and assign the value of 2 to x and you print 2, and similarly stepping your function instance would yield 3, which is now going to get printed. So what would happen after that is that your first for loop is done and your second for loop gets started with its execution, and a brand new frame is created for this function call of the generator f, and what would happen is execution of f would start from scratch again. So that's going to go hit yield 1, and 1 is now going to go into the variable x within the second for loop, and then you're going to get a printed output of 1, and similarly you'll get values of 2 and 3. Alright, hopefully that makes sense. Let's make it a little bit more complex by nesting two loops over here. So I'm going to actually nest another for loop. I can't use the same variable x, so I have to use a variable, different variable. Let me use y, and let me go ahead and print both values of x and y. Let me step through from the first. As you can see, there are like too many iterations to step through with this example. I'll just like step through a few of them and then show you the final output. So let's try and understand what's happening here. So we have the first for loop where we create one generator object instance, and what would happen is you have a frame created for f. So x will now have a yielded value of 1. So as you can see, x becomes 1, and the code execution moves on to the next line, which is going to be the second nested for loop. So what happens now is you're saying y is now supposed to take the values generated by this generator object instance, which is a brand new one. So what will happen now is a new frame gets created for this inner for loop, and your execution of generator starts from the beginning. So it will yield a value of 1, which is going to go into y. So when you print x and y, that's going to print 1 and 1. So notice that now the next line of execution is actually the next iteration for the inner for loop. As with any nested loops, the inner loop gets executed completely before proceeding back with the outer loop iteration. So similarly, what is going to happen is your x value remains to be the same, but y gets updated to a yielded value of 2. So when you print x and y, that's going to print 1 and 2. Similarly, the next iteration of the inner for loop is going to get a yielded value of 3, and that's going to print 1 and 3. So if you keep stepping through, you'll see that it actually prints all the combinations of these three values. Alright, so let me quickly talk about what exactly is generator object. So recall that when we did a print of f, we saw something which is called as the generator object. So instead of printing this particular generator object, I could actually save it in a variable, and let me call it g, which is now going to contain the generator object returned by f. Alright, so let me quickly step through from the first here. So okay, let's see what's going on here. So we have the function definition for f, and then we go ahead and call the generator function f, and assign whatever is being returned as the generator object instance to this variable g. So one thing to pay attention here is on the fact that we actually don't have any return statements in our function f. Despite that, the function f actually returns a generator instance. So this is kind of true for every generator function. It always returns a generator object instance. So let me talk about what you can actually do with the generator object instance. So you can use the generator object instance as a parameter to a special function which is called as the next function. So the next function is meant to work on generator objects and a few other things which I'll be covering in detail shortly. So let me first show you an example as to what the next function call does in this particular example. I'm going to go ahead and assign the return value of next to value v1. And if I step through from the first, you'll see that g gets assigned to the generator instance, and the way that the next function call works is exactly how you invoke the generator function call using a for loop. What will happen is next will go ahead and call that function, and it will return the same value, which is the value which is yielded by the function first yield that gets encountered if it is the first function call that you make with the next. So what would happen in this case is the first yield is return value is sending the value 1. So that will go into the variable v1 over here. So let me show you what would happen if I call next again. So as you can see, next call again will lead the function call to continue from the second statement, which is yield of 1. So the value of 2, which is being yielded by the function generator function f, will go into the variable v2. So if I try to assign the third variable here with v3, what would happen is the value 3, which is yielded by f, goes into the variable v3. Alright, so one important thing to note here is to the next function call, you need to actually pass the generator object and not just the generator function itself. So the generator object and generator function are two different entities. So the function call itself is given by the function name followed by parenthesis, whereas the generator object is what the generator function actually returns. So why is this significant? Let me actually show you this example with two different generators. Let me initialize two different generators and let me call it G1 and G2. So let me actually show you what happens. Instead of assigning the value, I'll go ahead and do a print so that we can actually see what's happening with these two different generator instances. So let me try and interleave a next function call between those two instances. All right. I think those examples are good enough. So let me step through from the first. So we are creating two different invocations of the generator function f over here, which generates two different generator instance objects. So each of those generator instance keeps track of where that particular function call for f is currently at. So the first invocation is for next of g1, which is going to yield a value of 1 because we are just getting started. So that prints 1. So now when I call the next function on g2, remember that G2 hasn't actually started an invocation for f, so that will start a brand new invocation for f, and that's going to yield a value of 1 as well. So what would happen now when I call the next function on G2 is that G2 remembers that it has left the previous invocation at the statement which is yield of 1. So it will go back to that statement and run the statement after that, which is going to yield a value of 2. So now 2 is going to get printed. So now looking at this next statement, when we invoke the next function on G1, that again remembers where G1 left off, which is again at yield 1 statement. So it's going to go ahead and run yield 2 and yield a value of 2. So that's going to go ahead and print the value 2 when we invoke next of G1. Similarly, when you call next of G2, it is supposed to print a value of 3 because 3 will be yielded. So the final thing that I want to show you with respect to this particular example is that when you do a for loop on your generator function, you're actually doing a for loop and iterating over the generator object instance that is actually returned by the generator function. So the way to think about that is, let me actually get rid of the second generator object instance, and let's just keep the first instance. So an equivalent of the for loop that we covered in the previous versions of the example would be for x in G1 print x. As you can see, it actually prints all three of the yielded values in that particular instance. So the next function invocation call is what exactly happens when you iterate over the generator object instance. So next gets implicitly called for each of the iteration of your for loop over here, and the value gets populated, returned by the whatever the value is returned by the next function will get populated into the variable x over here. So of course you can do things like you can explicitly call the next function inside your for loop. That is let me go ahead and print that instead of just calling the next function. That's sort of going to throw things a little bit off. I would recommend you to not experiment with such things because clearly the for loop itself is meant to implicitly call the next function for you. Alright, so let me switch back to the slides. I want to quickly jump back to the prime example. I'm not actually going to tell you how to write the code for this. Sorry, I'm not going to tell you how to run this code, but I can tell you how to write the code. So for this particular example, instead of appending each prime number that you find into a list over here, all that you need to do is you need to have a while of true and infinite loop and keep yielding every prime number that you find. Instead of appending it to the list over here, you need to keep yielding it. So I would strongly recommend you to write your generator version for this code and test whether you are able to understand this concept of generators. Alright, so moving on, I'm going to move on to the second part of this lecture, which is a little bit of scary vocabulary about iterations, iterable and iterator. So let me tell you what exactly is iterable. So whenever you have a for loop in the form of like for x in something, so anything that can go there is something which is called as iterable. So let's take a look at a quick recap of what are examples of iterable. So the first example of iterable would be any sequence. So recall that this kind of a for loop will work for any sequence which includes list, string or tuple, or even the range function which is meant to return a sequence. Alright, so that has to do with the definition of the term iterable. So there are other things which are iterable but which are not a sequence, and examples of that would be the dictionary dot keys function and dictionary dot values function. So these are special functions which return iterable sequences. So why exactly are these not, they return iterable. Why exactly are these two functions not returning a sequence? So that's because you can iterate over whatever is being returned from keys and values, but you can't do other sequence operations like slicing or indexing or anything like that on whatever is being returned by dictionary.key and dictionary.values function call. Alright, so another thing which I want to point out is anything which is iterable can be converted to a list, which sort of creates this fancy loop over here. So what do I mean by that? So for instance, we know that string is a sequence which is iterable, and based on that fact that you can convert anything which is iterable to a list, you should be able to convert your string to a list. Following the same example, since your dictionary.keys is iterable and anything which is iterable can be converted to a list, so you can convert your dictionary.keys to a list as well. Alright, so the next term that I'm going to throw at you is something which is called as an iterator. So a lot of programmers actually confuse the term iterable with iterator quite easily. So let me clearly define both of these terms. So what is an iterator is that you can create an iterator for anything which is iterable, and what is confusing in general for programmers is iterators themselves are iterable. So let's take a look at an example over here. So the first question is, how exactly can you create an iterator? So for anything which is iterable, you can call the iter function, which is going to return you an iterator, and you can using an iterator, you can always call the next special function which is going to return the next value which will be returned when you use that particular iterator. Alright, so you can create an iterator using the iter function call, and an iterator is entirely different from what is called as an iterable. So let me actually expand this a little bit to include what we have covered as part of today's lecture. So the yield keyword implies that you have a generator function, and a generator function always returns a generator object. So a generator object is an iterator. That's because a generator object is actually iterable, and you can call the next function on the generator object. Hopefully that makes sense to you. Let's actually I just want to add a word of caution one more time. I know that I already mentioned this. A lot of people confuse generator with generator object. So generator function is entirely different from generator object, and they're not the same. A generator function is the function itself, whereas generator object is the object that that particular function returns. Alright, so to make the difference versus iterable and iterator more clear, so let's take a look at a couple of examples over here. So before that, I just want to define it quite clearly. If there is some x, and if you have a question asking is x iterable, then you can easily answer that question by saying, does iter of x work, whether that particular function call returns an iterator over the iterable x. If it works, then yes, x is iterable. So let's consider another question which is asking is y an iterator. The way to answer this question is if you're able to call the next function on y and the next function actually returns a value from y, then y is an iterator. So use these two rules of thumb to determine whether something is iterable or an iterator. So let me actually show you an example over here where we have like few different things, and we are going to try and see which one of those things is an iterator or an iterable. So let me go ahead and copy paste this into my Jupyter notebook. So alright, so let's actually try both the iter function call and the next function call on each of these examples. So let me move to the other ones to a new cell. So we have a list here of integers which is called x. So let's first try whether the iter function call actually works on this. So if I go ahead and assign the return value of iter into a variable called it, clearly x is iterable because the iter function call is working. So let's let's only let's see if x is also an iterator. So how do we do that? We can verify that by checking whether next of x returns some value. So let me go ahead and try that. So as you can see, Python is complaining saying that x is iterable and that the list object is not an iterator. So clearly x is not an iterator. So let me go ahead and comment that. So x is not an iterator. So x is only iterable. Alright, so now that we created an iterator object for this particular iterable instance, so let me go ahead and show you how you can use the iterator object. So recall that you'll be able to do the special next function call on anything which is an iterator object. So if I try to call next of it, which is the iterator object returned by iter function, as you can see it gives us the very first value of the list. So if I keep going like that, let me see, let me actually add couple of more for the other two elements. So now it returns 1, 2 and 3. Let's actually see what happens if I make the iterator get me another item. So as you can see, the stop iteration exception is actually thrown. Once again, we'll be discussing about exceptions in the next lecture. So for now, you don't have to worry about it, and you should just know that this exception is going to be thrown. One more call of next it throws stop iteration exception. Alright, so that's the first example. Let's figure out what the other two examples are about. So we have something which is called enumerate. You have no idea what exactly enumerate is. So let's first try and see whether enumerate returns an iterable or it returns an iterator. So let me go ahead and try to call the iter function on y, and let's see. So it is working. So clearly enumerate is iterable. So let me call it like y is iterable because the iter function call works on it. Let's go ahead and see whether y is an iterator. So if the way that you do that is once again by using the next function call. So that's interesting. Y is also an iterator, so it's both an iterable and an iterator. So instead of assigning whatever is returned by the next function call, let me go ahead and print it. So interesting. Okay, so let me actually use this example to introduce you to the enumerate function. So let me call the enumerate function thrice. So I'm not able to tell whether you are able to see a pattern here or not. let me go ahead and actually change this example to use a different enumerated list. So if we replace the list to have alphabets instead of numbers, I think this example will be quite clear to you. So let me rerun this particular cell. So as you can see, enumerate returns two different values when you step through whatever iterable object it returns using that as an iterator. So the first value is clearly some form of numbering, and the second value is the actual value item in the list itself. So enumerate just returns you the index for each of those list items. That's what it's all about. Alright, so the second example, y is both iterable and is an iterator. So let's take a look at this third example where we have a simple example of z equal to 3. So let's try and call the iter function on, sorry, not on x, on z. Let's see if it actually works. No, it doesn't. So what would happen in case when you try to call the next function on it to see if it is actually an iterator? So that doesn't work either. So that's because primitive types like integers, floats are neither iterable nor an iterator. So this is neither an iterator nor an iterable. Hopefully these examples make sense. Make sure to step through these examples slowly so that you understand the difference between an iterator and what is an iterable. Alright, so I'm going to actually quickly get through the next few slides. I will be stopping after that and I'll not be covering the demo. So Alright, so let me quickly introduce you to the open function when it comes to reading a file. So open function is the function which enables you to read contents from any given file. So suppose we have a variable called path which is going to contain the absolute path to a file. The way that you can invoke the open function is by saying open of the path which gives you the absolute path to the file. So the open function is actually going to return you a file object. So let's take a look at what exactly you can do with that particular object. So the function clearly takes in a string argument which contains the absolute path to the file, and let's say for instance this is the content of the file. You have a bunch of lines over there. So the file object that you get out of the open function call is actually an iterator, which means that you will be able to write a for loop to iterate over the iterator, because recall that iterators themselves are iterable. So you can write a for loop saying okay, for line in f, recall that f is an iterator. So you can then do things like print line. So if you go ahead and test this, you'll see an output which is each of these lines getting printed on a new line. So observe that there are actually two new lines, the default one after the line and then this empty line that gets added. So that is because print itself adds a new line, whereas the other new line comes from the file itself. So file has a new line after every single line, and then print also adds a new line. So recall that the way you can get rid of this additional new line is by defining the named keyword argument end in the print statement. So if you redefine end to be nothing, then you can get rid of this additional print over here. Alright, so I'm not going to be able to cover the demos, but I'm going to actually add a couple of input files for these examples. You can feel free to write code for these demo programs on your own.